Okay, so you are welcome to today's tutorial. Today we are going to look at some general business application of integral calculus, specifically the rate of growth of sales. So these are some examples of some general business application of integral calculus. So let's start off this way. If the rate of growth or a sale of a function is known, or is a known function, let's say is a known function of t, which is maybe f of t, where t is a time measure, then the total growth or sale of a product over a time period t, right, over a time period t, can be given by the total sale or growth can be given by the integral of 0 to maybe to r of f of t dt, where 0 is less than or equal to t, less than or equal to r. So to understand these questions, this system more, we have decided to actually solve some general business application of integral calculus so that you can get a deep understanding of whatever we are saying over here. So not to waste much time, I would like us to move straight forward to the examples and then start solving them. So the example 1. Okay, let's solve it. The rate of a new product is given by f of x equal to 100 minus 90 exponent negative x, where x is the number of days the product is on the market. So the question is, find the total sale during the first 4 days. So let's take this one for instance. If for the first day you made a sale, that is the sale for the first day. So what is the sales of the other days in case you went to the market 4 consecutive times? So what is the accumulated sale that you have done within that particular time frame? So in doing that, that's where this definite integrals comes in. So in applying the definite integrals, we are being asked that we should find the total sales during the first 4 days. And in the question, the rate of a new product is given by, right? So they have given you the rate of the new product, which is the sales function, which is f of x equal to 100 minus 90 exponent negative x. So where x is the number of days the product is on the market, so they told us that x is the number of days the product is on the market. So based on that, let's find out the actual sale that were made during this particular time frame. So to find the sale, we need to find the integral of f of x. So the integral of f of x is equal to the integral of 100 minus 90 exponent negative x. But remember that we have a limit being given, and the limits that were given is from day 1, or let's say start from day 0, because day 0 not affecting, we want to accumulate from 1, 2, 3, and 4. So therefore 0 to 4, that will be our limit. And don't forget that we are integrating with respect to x. So integrating this with respect to x, what we are going to get is integrating 100, we are going to get 100x. And then integrating 90 exponent negative x, we are going to get a negative in front of whatever we have currently, right? So let's see something here. When we differentiate what is up there we multiply by what is up here. Now remember that the 90 is a negative, and therefore when we differentiate whatever is up here and we multiply here, we are going to get a positive. When we differentiate negative x, we are going to get negative 1, and therefore negative times negative, we are going to get positive. So we are going to get plus 90 and then exponent negative x, and don't forget that we have a limit of 0 to 4. So based on that, as usual, the fundamental theorem of integral calculus, the upper limit minus the lower limit, and therefore we are going to have 100 multiplied by 4 plus 90 exponent negative 4. This is our upper limit, and then minus 100 multiplied by 0 plus 90 exponent negative 0. You know we don't have negative 0, so we can just make it 0. And exponent of 0 is 1. So in all, we are going to get here be 400 plus 90 exponent negative 4. And then minus here will give us 0. And therefore here, since exponent 0 is 1, we are going to get 90 multiplied by 1 over here. So at the end of the day, it's negative 90. So then what is left is for us to simplify whatever we have. And then remember that we have been given that exponent negative 4 should be equal to 0.018. So when you do the substitution over here, you know it was given in the question over here. So in doing the substitution, the final answer that we are going to get, it's equal to 311.62 units. So if you want to solve it again, please start a video and then play everything over and at least solve it first before you start watching how I was doing it. So the second example about the general business application of integral calculus will be something quite simple. So let's start off with example 2. A company produces 5,000 units per week with 200 workers. So the rate of change of production with respect to the change in the number of additional labor x is represented as 300 minus 5x power 2 over 3. If 64 additional laborers are employed, we should find out the additional number of units the company can produce. So let's go over the question again. A company produces 5,000 units per week, that's per week, with 200 workers. So with 5,000 units per week that they produce, they do it with 200 workers. And also, the rate of change of the production with respect to x in the number of additional labor x is represented as, so the rate of change of production, right? So we can say if production is P, then the rate of change of production will be dP d x, because we are different, it's with respect to x. So they are saying that the rate of change of production is 300 minus 5 exponents 2 over 3. So now we have our rate of change of production. So if 64 additional laborers are employed, find out the additional number of units the company can produce. So look at this place. Look at this place. They said that if 64 additional laborers are employed, we should find out the additional labor of number of units the company can produce. So all boils or comes down to of definite integrals, right? So now let's assume that we are starting off from 0 workers. So from 0 workers, let's say when they are using the 200 workers, this is the function that they have already, the current function with the 200 workers and then the 50,000 unit that they produce per week. And they use those values to come out with this function. And coming out with this function, they are telling us that we should find out if 64 additional laborers are employed. Now, 64 additional workers are employed. So based on that, we can say that, excuse me, we can say that this is what we have now. So this means that if no worker is employed currently or right now, no worker is employed, we can put it over here to see the production rate which is going on. But let's see what we go. So this means that our limit will start from 0 to 64 because we are looking for 64 additional laborers. If they are being added to the 200 workers, what will be the number of units the company can produce? And then, as I said earlier on, these 50,000 and then 200 workers were used to come out with this production function, rate of production function. So in that case, we are looking for production, the production function itself, right? This is the rate of change. So for any one additional change, or let's say for any one additional change, this is how the rate of production changes. So this is the formula for the rate of production. So if they add one additional employee worker, what will be the rate of change of the production? This is what will come when we put it inside. So basically, it's more or less like it's a gradient function that we can use to determine the rate of change at the various steps, right? But this one, we need the accumulated value. In this case, we need to apply the method of integration. We need to apply the method of integration. So applying the method of integration, as I said, the limit will start from 0 to 64, and then our function will be 300 minus 5x power 2 over 3, and with respect to x. So based on this, as usual, let's find out our production function. So our production function P is equal to the integral of, because we are finding the integral of both sides, so it was the P dx, and then we found the integral of both sides. So we go to 64, 300 minus 5x power 2 over 3, or dx. So find out this one, what we are going to do is integrate the right hand side. When we integrate the right hand side, we are going to get 300x minus 3x power 5 over 3. And then don't forget that we have the limits at 0 to 64. And therefore, by substitution, we are going to get 300 multiplied by 64 minus 364 exponents 5 over 3. And then you know the 0 will give us 0 true values. And therefore, at the end, you are going to get the production if at the number of units the company can produce if they add additional 64 laborers or workers to the existing one, which is 200. So therefore, we are going to get produce about 16,128 units. So the number of additional units produced will be around, as I said earlier, 16,128. So the total number of units produced by maybe 264 workers will be, right, let me find here. So the total number of units produced by that's 264 workers will be the existing one, which is what? 50,000 plus 16,128, which is equal to 66,128. So as I said earlier on, they use these ones to just come out with the rate of change of production function over here. So since we have the rate of change production function here, this is telling us that for every additional worker that they add, or additional labor that they add, right, the production increases, and it increases in a certain amount. And we don't know the amount, but they are giving the function. So based on that, if we add one worker to the existing 200, we are going to produce some particular units in addition to what we have already. So that's why we apply the method of integration, and we started from 0 to 64 over that particular function, 300 minus 5x power 2 over 3 dx. In doing that, we got to the fact that accumulated units from 0 to 64 is going to give us 16,128, and therefore that is the 64 employers or employees. And therefore, if 200 is producing 50,000 and we add that 60, we have a 64 also producing 16,128, then in total of 264 is going to give us, as I said, 66,128. So thank you very much, and thank you for watching. Please share the video, comment, and see you in my next tutorial.